Ta-da! And welcome to Josef's Model Railway and Toy Room. I'd like to thank you for joining me as we kick this episode off talking about wiring, and a little bit different from everyone else that starts talking about model railway wiring when we're getting into points and DCC operation, block detection, all of these sorts of things. Things like that will be discussed in later videos, but we're going to come back a layer from that, and we're going to talk about wiring from the electrical system itself. So effectively, the outlet on your wall where your electricity flows in and comes to your layout. From that point, we connect into our controllers, and then the power is obviously stepped down. We're coming out into a DC form, usually at about 12 volt or what have you, and it's quite a safe environment for us all to work in from there. I just want to talk to you a little bit from that. Now, we're in Australia, we use 240 volts here. Other countries like America, they're using 100, 110 volt. So it's very important I need to make this disclaimer. Any electrical work needs to be carried out by a qualified or a licensed electrician. That's all I need to say about this. My interaction from this may be a little bit different from other people. There is a lot of stuff. I would never attempt anything that I cannot handle. But most importantly, in the industry that I work in, I work closely with a lot of electricians and electrical engineers who are not just colleagues, but are also close friends as well. So if there's anything that I'm sort of trying to challenge that it could be tricky, but labor intensive, I will simply consult them. They'll say, you'll need to proceed with this. You'll need the required segregation for this. I'll basically do a rough-in or pre-wire. They will then come back in with their appropriate testing equipment to make sure, checking for earth leakage, things like that, to make sure, just check that everything I've done is, above board. If that's the case, it's then up to them to then provide the necessary connection to the actual circuitry on the house or wherever we are. So, since we're building this layout and sort of flying by the seat of my trousers here in the sense that we have a conceptual plan of what's going on, but as we'll discuss in a video at some point, we need to talk about the operation and control. I don't know where the Hornby DCC Elite controller is going to be. I don't know where we're going to put these point controllers exact. No idea. So in which case, that'll be in another video. Today, we're just going to talk about provisioning for the future where we can. Bus wire. So if you're looking about the operation where I'm going to be laying in the bus and talking to you about cutting out and putting in the dropper wires and that's not going to happen in this video. I just want to put that to bed right now. So the approach that I've gone with here is basically we just need to turn the power on at a power point, and that's going to light up our controller and any additional boosters we need to get the track power flowing. And then ideally we would have a secondary switch to turn on all our accessories, whether it be points, whether it be the lights we use around the yard or signals and what have you. So the whole idea is we can comfortably just usually plug in into a standard controller. That's fine. But I'd like to leverage the power out a little further. Again, we're not going to be sucking huge amounts out of this. This is not a complicated layout. We have not got stacks of accessories being run here. We're keeping it simple. And the step where I'm going to be running two separate circuits is completely overkill, but I think it's going to make sense shortly. So let's just see what I've been up to and see what I've come up with. So, as you can see, we've glued and now pinned down these sexy cork curves. And so while we're waiting for all this lot to dry, we'll carry on with this video. So what you're about to see is the electrical wiring for this layout and this layout only. If you'd like to come and pay me a visit and say, I need to plug my phone charger in or what have you, well look, there's a PowerPoint over there. I'm not going to disappoint you, but you will not find any access to my model railway power. Right, well, some options. Look, we could have just explored putting some general power outlets and strung them together underneath the board. I really didn't want to have to be using some conduit like what we've done here, and it would be a nightmare trying to go up and in through the walls to achieve that. And yes, I do need to change that logo to 007. It would seem a little more appropriate and humorous for this room. Okay, so we've got our standard GPO sitting over here. What we're going to do is we're going to track it up to where the board is. We'll most likely just pop our switch just here, and then in the same thing behind the cavity, we'll come through junction box over here and run our cables out and through there. We're coming up to a little junction where I'm going to wire the switches back, and then you'll see there are indeed two little holes just there, and we're going to send 2 runs of power cable out. For those of you who may be following my other channel regarding hi-fi, you'll notice I have a chapter on there regarding cables and power, and I take power exceptionally serious. Being in the industry that I'm in on either avenue of what I do, I'm very conscious of what happens at the other end of the wire. It's very tempting for a scenario to be coming and setting up with 2000 watts of refrigeration equipment, and on the flip side someone decides to plug in a commercial urn or a bain-marie that's got 1500 watt heat lamps and that. You need to understand what you're drawing, what you're using, and of course your peak demand that's going to push out of that circuit. So everything that I do in general is always well under that. I'm overthinking the whole situation, but I don't think it's a bad thing. The last thing we need is to have a problem with the electrical side of life. So yes, I could have put those GPOs into a piece of conduit and linked them together. But the other way I thought I'd go about it in this situation is to use the blind snake rapid plug base. Now in Australia, certainly, and it's by law in new houses of homes, gone are the days there used to just be an electrical socket, piece of wire you unscrew from the light fitting and then put the new fitting on. By law now there needs to be an actual power outlet in there. So this is one of the popular brands. Look, there's different ones out there, but I'm just going to talk about this one for today and the applications that we're using it for. First of all, obviously it comes in a box of 10, and as you can see, the blind snake, I mean, there's no doubt about it, the wire, and then the fangs come in and grab it. So basically what's happening, they come in a pack of 10, they're nice packaging, I'll give you that. And the whole idea is, as you can see here, if you're an electrician, you're on your scissor lift or whatever else, and you're up into the ceiling, you can carry them on and install and install and install, and away you go. So there's really nothing too complicated about it. The whole idea is that the unit just separates. Your piece of cable will sit in the middle. Now, again, in Australia, we use 2 standard sizes. The 1.5mm, which is the stuff we're going to be using on this application, which is what you're going to find to drive a lot of your light fixtures and what's sitting in the ceiling doing all the lights in your house. And then, of course, for all your general power points and that around the home, it'll be the 2.5mm cable is what you're going to be using. And the reason I just point that out is that we are going to be using just a 1.5 for this light duty type of application, but even, which would be ideal because that's what we're talking about, light fixtures. But if you are doing, for other applications, this insert that pops out, which is a spacer, which is for the 1.5 to sit perfectly into, as you can see, lovely. If you take the spacer out, you can just use 2.5 and in it goes. So that's something to think about. Also, I have old reels of cable at the moment. By old, they're 5-6 years old. There's nothing physically wrong with them. They're absolutely fine. Just with all the new ones, you'll actually find that the active side will have a stripe against it, and that becomes a little bit useful in this next step. But it doesn't really matter. First of all, in the box, I should point this out anyway, for anyone that didn't know, you also get a bunch of these little things. And of course the company does a great website and YouTube videos to show how it all works, and again, consult your electrician and all the rest of it. I'm just telling you about it anyway. You get these little end caps, and the whole idea is you just trim the end of the cable. The active, the neutral, and the earth will slide on in, and then this clips into the end of the unit, and then lock it off, and that's the end. Which is exactly what we're going to use at the end of the layout here. So with that adapter removed, And if the camera can focus in, you should hopefully see there's a tiny little blade in there. And that's exactly what it is. And that's the one that's going to penetrate the ground or the earth wire. And then on either end, there's 2 slots for 2 blades to come out, one on either end to pierce active and one on the neutral. And so what happens is it's marked quite clearly neutral and live. So you just need to make sure the cable is obviously aligned in the right area. You'll push it down so the earth becomes penetrated. We slide this on, lock it in, and that's an exceptionally solid connection. For those of you that are asking, well, hang on a minute, what happens if we have terminated it and we knew that the neutral was on this side, but it's not a marked cable, and then all of a sudden 10 years down the track we're left with this? That plug's no good to us. Of course it's good to you. All you've got to do is take a pair of cutters or a blade and just gently nick the end away just so you can see whether it's red or black. And from that point you know which way your plug is going to have to sit, and then lock it on. So as you can see, this is an end one I've just done, and there's the end, so no one's going to get hurt or anything like that. And the great thing is there's a release. If we push and open, we can undo it and reposition or what have you as needed. Of course, I'd unlikely ever be to do that. So that last one's going to come up and just sit over here, and then we'll just put a bit of capping on it. I think as you can see, they'll just tidy it up a bit. I mean, it's all safe enough as it is, but I want to get down here and play with Lego, and the last thing I need is for someone to get too creative hanging something off of this. Now, I just want to talk to you for a moment about cable identification. I'm going to be talking to you about these IPA studs. Now, these were very common in Australia in the 80s and 90s. Of course, since then, we've now moved on to Clipsal Series 2000. Well, actually, we're moving on away from that now. Well, we basically just take a standard clear blank Mech and we can run a label maker through it. But these are basically a pretty stock standard sort of arrangement. It's just basically a number that's been punched onto a little coloured piece of plastic. So you've got a 1 there, we've got, and made to any colour sequence and style you like. In my situation, the way I've got these organised is I've got 1 through to 12, because we use a 3-phase power and we use a distro box out of that, which means it gives us 12 dedicated 10 amp circuits that we can use. So that's 2400 watts, 2400 watts, 2400 watts, 2400 watts, 2400 watts. You get the idea. And then obviously I get the others just done in A, B, and C, so I know which phase respectively other circuits have been wired off on where necessary. Now in this particular demonstration, we will just be using one standard circuit. There isn't anything unusual here, and we don't use this number system in the house or anything like that. That's all to do with the shed. So what I thought I might just do is we might just take the A and B perhaps. We're just going to cut that off and then attach them accordingly, and all we're going to just do is 2. I've got 5 sockets laid out there, but I am only going to mark 2. I mean, first of all, the secondary one, and let's call that B, it only has 1 outlet and 1 switch, so we'll pair them off, and then we can just match A to any of the others, and people know how that's going to be marked out. Is it necessary? No, not really, but just because the outlets are all the same and we're trunking them accordingly, it just helps identify it to the average person. And so you can see under the board here, we've basically got our switches done here for B and A respectively. A will be the easiest one to reach. When I come in from the other side, walking up into the distribution block, it's come down and been terminated by the electrician through this existing power point. And as you can see, we've obviously attached the A to turn on that, and that's what's powering 4 of these strips evenly spaced on the back wall here. So here we are with the B circuit. Again, it's only going to be a single one, probably the one that's going to turn on the local power to the lights or the points or what have you. Needed something to test it, so we just came down, grabbed what was on the floor, which was the Hornby DCC controller.
And you'll notice that there's a bit of a gap if I swing the camera this way. Why didn't I put it flush? And I agree that would have looked much nicer. But the reason I left it off was to make use of this rail underneath the fiddle yard. So when you've got the transformers for equipment like this or whatever could be there, we can obviously cradle that up nicely and keep it up off the ground and out of the way. And then whatever is being plugged in, we can then just obviously send a bus rail up and wherever it needs to pop up onto the next layer up here. So for the moment, let's recreate the scenario. Here is our doorway. We would open it. We could come straight in, hit the light switch, turn some lights on, come straight over, and I just have to reach my arm, but sure enough, there's our switch. Turn A on and we'll have the track power and controller, and hopefully the other one will turn on lights and accessories. They're all tested and working, I know that's the case, but the whole idea was just to keep it clean and unified. I know we can do a lot of this stuff with remote control and controlling it from your phone and all the rest, but there's something so solid about having an isolation switch just to cut the power when you leave and not having hundreds of little switches you've got to go climbing around for. Another quick thing I'd just like to mention here is as we look across, we can't see anything, which of course is the point. But if I come and squat down, I still can't see anything. So I'm literally going to have to bring the camera, and I am just about to touch the floor now, and we can just make that. So if you're popping around to pay me a visit, you're basically going to have to get down on the floor to see what's going on here. Now that was the original point of this. I'm just trying to hide unnecessary cable where possible. In fact, if we do come down again, and I'm just going to squat on my knees here at a reasonable sort of level, well, that's fantastic. We can see that incline traveling up. Looks pretty good to me. That's where you're supposed to be looking. And of course, we're going to pretty it up a bit as we get down to there.
Well, that now concludes this video. I hope you've enjoyed. Thank you so much for watching. Again, you don't have to subscribe or follow or like or any of that. Just put these videos up where I can. Hope you enjoy them, and we'll see you in the next one. Stay safe. Toodles.